This is a practice trigonometric internal, and I've taken it from the TKI site, which you can get through the NCA maths pages. So here we've got the introduction. Maths and Amusement Park has two Ferris wheels. We've got the Kiddy-wheel that can get to a max height of 8 and the flying high max height of 43. At the amusement park, got Manu's taken the high one and Jade's taken the Kiddy-wheel one. They go on at the same time, so time's going to start the same for both of them. Because of trees, they can only see each other at certain times. This activity requires you to use information provided about the Ferris wheels to determine when Jade can see Manu. So we'll get more information later. You can see all of these things at the same time when you're doing an actual internal. But what's really important when you're reading through a task is to actually highlight important pieces of information as you go along. And here, the fact we've got that maximum height of 8 meters, we're going to use that later on. And it's really a good idea to think about that and keep it there to make sure you use it. And we've got that 43 meters max height for the flying high wheel. Okay, so here we've got the task, working independently. Of course, we want to identify the mathematical model for the Kiddy-wheel. Now, I'm not going to actually have it where I identify as it does in the task. We're actually going to find that model ourselves. We're also going to find the model for the flying high Ferris wheel, and then we're going to use that information to find out when Jade can see Manu. And then we've got our general piece of information here about how well we communicate our ideas is going to determine our grade. Okay, here's the rest of the information that we need to solve this problem. So both Ferris wheels place passengers from ramps at their lowest points, so that's important. We're going to get the minimums for our trigonometric functions. The seat is at the same level as the ramp at the loading point. Jade and Manu start their rides at the same time. The Kiddy-wheel reaches a maximum height of 8 meters. We know that already, and its ramp is at 0.5 meters. That's important because that's going to be the minimum for the Kiddy-wheel. And the ride makes 2 revolutions per minute. We'll keep that for later on. The flying high Ferris wheel reaches a maximum of 43. We already took that. And its ramp is 3 meters above the ground. So that's the minimum for the flying high. And that makes 3 revolutions in 2 minutes. So we can use those 2 pieces of information there to find out the periods. Here we go. This tells us how they can see each other. Due to the trees, buildings, positions of the rise, Jade can only see Manu for some of the time. For Jade to see Manu, she needs to be more than 5 meters above the ground. Manu needs to be going up and more than 5 meters above the ground, but less than 20 meters above the ground. So we need to find out when Jade gets to 5 meters. We need to find out when Jade first reaches 5 meters, because we know that Jade's going to start at 3 meters, and then when Jade first gets to 20 meters, and then we want to see how often that repeats itself using the period. Okay, so let's find the formula for the Kiddy-wheel. On the actual practice task, they give you 4 to pick from, and you've got to work out which one is the correct one. But it's a good idea to actually work out the formula and find the one that meets, because on the next part of the task, you do have to find the correct formula. And this way you get to find the correct formula and you can kind of verify that your technique is correct. Okay, we know the maximum height. We know the minimum height. We recorded those last times. We also know that the ride takes 2 revolutions in 1 minute, which means it does 1 revolution in 30 seconds. Now remember, it starts at the bottom, it gets back to the bottom in 30 seconds, which means the time to the first maximum, the first time it gets to 8 meters, is 15 seconds. Now, it's important I've used this bit that the period is 30 seconds here, because we're actually shown that we understand some of the features of our trigonometric function. We've also got here, A is the amplitude, which is the height, spelled incorrectly, from the mean. Now this is important. Again, we've used the term amplitude. We're explaining we know what the amplitude is. So let's see. So it's going to go from 8 to, from 0.5 to 8, which means it's going to go 3.75 above and 3.75 below, as the formula tells us. Then we're going to talk about D. D is the mean height or the central position. So that's going to be the average of those heights. So let's take the maximum, the minimum, and divide by 2. Then we're talking about the period again. Here again, we've got these things here. We're talking about features of our graph, and then shoving that 30 in there, we get our pi over 15. And C, the time to the first max of sine x is after a quarter of a period. So what I'm talking about there is the shape of a sine graph. After a quarter of a period we get to the max, and that's what gives us this formula here for C. So again, I'm talking about the features of the graph, and now all I've got to do is shove that 15 into here, shove that 30 into there, and I get that C equals minus 7.5. And there we've got our formula that h of t equals this lot here. Okay, so let's find the formula for flying high. The technique is going to be exactly the same. I've just changed it to a capital H so that we can tell the difference between the two. So we know the max height, we know the min height. This time we know that a ride makes 3 revolutions in 2 minutes, or 3 revolutions in 120 seconds, which means it makes 1 revolution in 40 seconds, so a period is 40 seconds. Time to the max is going to be half of that then, because it starts at the bottom, so that's 20 seconds. We find A in the same way, B in the same way, we find B in the same way, and we've still got this piece of information again from last time. So we've got our formula to find C, so we get minus 10, and we have our formula here. Okay, so let's find out when the kiddie wheel is in the right position. So we want to find out when it gets to a height of 5. So we end up with this. So first of all, we're going to divide by we're going to subtract 4.25, then divide by 3.75, and then take the inverse sign of that value. And the two values where within the first period where it's okay, 0.201 and 2.940, and we can add on multiples of 2 pi because of course it keeps because trigonometric functions are periodic. So if each of these we multiply by 15, divide by pi, and then add 7.5, we get this here, which simplifies down to this. You can actually get to exactly the same position by ignoring the 2n pi and just multiplying these values by 15, dividing by pi and adding 7.5, and then just adding on the 30n, because we already know that the function repeats itself every 30 seconds. Now, what values do we want? Well, we know that it starts off at 0.5. It's going to get to its maximum at 15, so we know it's going to be either side. So these values are good. Over 2 minutes. Now, why over 2 minutes? Well, over 2 minutes, both wheels are going to be at the bottom together at the same time, because the kiddie wheel gets there every minute, the flying high gets there every 2 minutes, so it means over 2 minutes they will both be in the same position. So we've got from 8.46 to 21.54. Add 30 seconds onto both of those, we get that period. Add 30 seconds onto both of those, we get to that period. Add 30 seconds onto both of those, we get to that period. Now we're not going to continue because we have another 30 seconds and we're past 2 minutes. Okay, so now let's do it for the flying high wheel, and we've got 2 separate equations to solve. One when it gets to 5, remember it's start and it's got to be going up, so the very first time it gets to 5 will be right for us because it's starting at 3, and then when it gets to 20, and the first time it gets to 20 will be good to us. The second time it gets to 20 is no good because all that time it's above 20, and the second time it gets to 5 is no good because it's on its way down at that point. So let's do this one here. Just like before, we end up with these values here. Now remember, n can be positive or negative, so if n was 0, we'd have 37 and 41. If n was minus 1, well, this would be below and before they started, but this would be when when just after it started at 2.87. So that must be the very first time that we're in a position to possibly be able to see, and every 40 seconds after that. We'll do the same thing here, but this time we want the very first time that we get to 20 meters. So again, maybe it's 30, maybe it's 49, but if n was -1, well, that time's not valid, but this one is at 9 seconds, so it must be the 9-second time. So what are the times over 2 minutes? Well, we've got 2.87 to 9.04, and then we're going to add 40 seconds on because we've got a period of 40 seconds. We've got these ones, we've got these ones, and no more, because after that it's more than 2 minutes. Okay, so when can they see each other? So what we're going to do is look for overlaps in the time. So if we look at, is there an overlap between, well, in fact, better starting here, between 2.87 and 9.04? Yes, there's an overlap between these, and the overlap starts at 8.46 and will end at 9.04. What about within this time frame here? Yep, that is because that 42 is within this time, the 49 is within this time. So definitely there's an overlap of all of that time. Well, what about within here? Within here. Well, no, that 42 is outside, so 82 is outside this one, and it's also outside this one, and the 89 is outside this one and outside this one. So these are the only times. So it's important that we say at the end and put it in context, they can see each other from 8.46 seconds to 9.04 seconds, and from 42.87 seconds to 49.04 seconds. So I hope you found that helpful. It's really important to communicate what you're doing. It's not an English essay, it doesn't have to be perfect. We want to make sure that we mention some of those trig functions like we did earlier, the period, the amplitude, the mean value and so on, the maximums, the minimums. And in the end, it really is important that we make sure we answer the question that they gave us to do. Stay in infield with Winfield.